For example, the external components such as the feedback resistors, the input and output capacitors, those are really the only thing you need with our module. So here, the passive components on the outside versus having the inductor, which is usually the largest part outside of the chip itself. So that'll the inductor will add a lot of space, but this integrates it within the chip, so a lot smaller size.
Hello ipXchange community, welcome to another video from CES 2024, this time again with MPS, Monolithic Power Systems.
Hello ipXers, yet again we are here at the MPS booth with Adrian, who is now going to tell us about his power modules. Off you go, Adrian.
Hello, so our power modules here at MPS, so with the power module, it's an integrated IC with an inductor. So here we have our modules at various power levels. So basically what it is, so buck boost, buck, if you're stepping down or stepping up voltage, you'll need a inductor. So this module itself integrates the inductor within the chip, makes design a lot easier for the engineer, a lot simpler board layout, and a lot more power dense. So in terms of efficiency, it is on par with the discrete options as well, and just makes it a lot simpler design for the engineer.
Right, so that's a discrete design with multiple chips
Yes.
on the board doing the same job as your module.
Correct.
Which is a single chip solution.
Yep.
So is that the only single chip solution on the market, or are there other single chip solutions on the market?
There's others out there, but I will say with ours, we are the, in terms of energy density, we do have the world's smallest isolated power module. So here the MID modules, they are, we do claim that they are the smallest compared with our competitors. And in addition to those, the other ones, as you can see, are very small. So
they are very small.
So an entire inductor goes right there. So in terms of energy density, we are leading in that area.
Right. So forgive me, but something that you showed a discrete design solution there.
Yes.
With something as small as that. Obviously, we wouldn't. But this isn't replacing that at that point, is it?
Well, I would say it is replacing a lot of it.
Right.
So,
Okay.
For example, the external components such as the feedback resistors, the input and output capacitors, those are really the only thing you need with our module. So here, the passive components on the outside versus having the inductor, which is usually the largest part outside of the chip itself. So that'll the inductor will add a lot of space, but this integrates it within the chip, so a lot smaller size.
Right,
Yeah.
right. So this is all about efficiency, taking up less space on the board, taking up less space in the overall design.
Yes.
So will most of your customers and our listeners, will they be starting with a discrete design and saying, how do I make that smaller? Or will they be starting afresh?
They'll typically be starting with a, it could work either way, but typically the way I observe it is that customers will have a discrete solution.
So they already have that?
Yeah,
Yeah.
And
okay.
they're like, how can we condense this? How can we make it smaller? Because there's a lot of space constraints on the board, especially with products today becoming smaller and you know, more handheld. So we do see those space constraints coming from customers, and we always point them towards our modules because it is the most compact solution.
Yeah. So where's the so for this particular module here, where's the most obvious applications that you replace this big discrete board and replace it with one of these?
Yeah, so for DC-DC, really anything that needs power, if it has an on switch, that's an opportunity for one of these chips to be used. So think of anything battery powered, so that's DC-DC going from the power of the battery to something that lights up. So really anything that needs power, this can be used in.
Right, so is that, would that be predominantly industrial electronics?
Yes, I would say. Yeah, industrial, consumer electronics, automotive we'll touch on later, but these chips can also be used.
All right.
Yeah.
So if somebody wants to work out, how do I've got that right now, I want that. How do they evaluate that? How do they come to you in order? Is there an evaluation board available?
Yeah, so they can reach out to us on our website. Our website does do a great job at showcasing our eval boards and all.
You say your website. or of course ipXchange.tech. Back over to you.
Yes. So, and then also monolithicpower.com. We'll have our modules there. You can easily access all of our solutions, look through our eval boards, and see which module would best fit your power requirements. So it depends on the voltage and the current that you need, and then from that you can determine.
You then
which
choose
module.
this big library of parts that are actually available.
Yep.
Okay, good. And then in terms of volumes again, we're talking big, high volumes.
Yeah. Big high volume. So anything hundreds of thousands, millions would be considered high volume.
Right. Good. Well, thank you very much to your power module introduction.
All right. Thank you.
Thank you. Next one.
All right.
This time, Guy and Adrian will be discussing some DC-DC power modules. We all love those, so enjoy the interview. So, that was another interview with MPS. We've got 2 more to go from CES 2024. And yeah, very interesting technology, remarkably compact, and it's nice to have an integrated inductor in there. So if you want to learn more about these devices, you can follow the links to the board pages on the ipXchange website and apply to evaluate them today. Keep designing.
Hey, yo, where my engineers at?